There's over 100 computer character sets, including code pages specific to specific countries, such as code page H62 for Israel and 737 for Greece. The original computer character set was EBCDIC, and it was IBM proprietary. This was replaced by ASCII around the time Unix came into being, and when PDP 11 mini computers were all the rage. And basically ASCII defined visible characters between 32 and 127 decimal, and defined control characters between 0 and 31, such as 7 for the bell and 12 for the form feed. This left the top 128 characters undefined and up for grabs, which resulted in a lot of people grabbing them, such as the code pages mentioned above, or the IBM OEM character set. A lot of these character sets involved line graphics, where you could create boxes and graphical figures with the top 128. The character sets that used all 256 bits of the byte were generally referred to as ANSI standard character sets, but whose standard they were seemed to be defined by who you were talking to. Unicode was an attempt to create a real international standard which would show any character, including very graphical ideograms such as those used in Japan, Korea, and China, by using one really big character set. And in order to do that, of course, they had to use more than one byte. And this resulted in fact, Unicode breaking up into a lot of different standards, ranging from 2 bytes all the way up to 6 bytes. Some of the Unicode standards include UTF-8, which is 1 byte that largely maps into ASCII. UCS2 or UTF-16, which is 2 bytes. UTF-7, which is like UTF-8 but guarantees the high bit is 0. UCS4 or UTF-32, which is 4 bytes. Windows 1252, which is also known as the Western European Standard. ISO 8859-1, which is known as Latin 1, etc., etc. The basic point is, if you don't know how strings are actually encoded, you are SOL or aka FUBAR in reading them. So what is the default encoding standard of C#? Before I answer that, I should probably explain why I'm even asking the question. I basically wanted to update a program I wrote and did videos about quite a few videos ago, and I wanted to have 2 buttons, and the buttons essentially transferred information from a list box up to a text box, or from a text box down to a list box. And I thought it would be great to have text that explained what they did, and also have an arrow pointing down and an arrow pointing up. And so I started to look for graphical characters that would handle this. And one of the first things I did was go back to a program I wrote in video 21, which was a console program. And this console program was called char01.cs. So if we look at that code by going in char01.cs, you see it's an extremely simple program where I basically set a bell character equal to 7 in 2 different ways, with a hex constant and with a char typecast. And then I write that to the console to make the bell ding. And then I go through all 256 characters in the possible 1 byte character set, and I show it as decimal, as hex, and then as a character using the char cast. So if we run this program, I guess I already expanded it. Oh, I think I said char02. But that makes the point I was going to make. Basically, this is like an ASCII character set. Everything up to 65,535 is undefined characters, are just displayed as question marks. If I run the actual original one, char01, which just does the first 256 character or 256 bits in a byte. See, they're all defined, so essentially it's an extended character set, like a code page. And if you go up to 41 hex, whoops, see, that's where the capital A begins. And if you go to 61 hex, that's where the lowercase a begins, and goes through the letters of the alphabet. And then there's various other characters defined. I hope I'm not making anybody nauseous with these. In fact, in the lower 0 to 31, there's some graphics characters which also act as control characters. Or no, the graphics characters are just graphics characters. The control characters are even lower down. Like a control character is 7 for the bell, or 12. I guess it is both a graphics character and a control character, because this would do a form feed, and A and D together would do a carriage return line feed. But as you can see, when I ran the variation of this program that uses 2 bytes, most of the 2 bytes are totally undefined, and the ones that are defined, I think it's just an accidental definition. It just repeats the normal ASCII characters. There's no special characters or anything. But when I go into Windows application and I do the same thing, I do a loop from 0 to 0xFFFF. 0x is a way of defining a hexadecimal literal as a number, much as /x is a way of defining it within a string. Where the /x actually will be a character, a displayable character, but the 0x is just a working number. And once again, I have the line formatted with as a decimal, as a 1:x that is a hexadecimal, and then as a character, which I typecast as a char. And if I compile and run this program, it actually takes a bit to run because it's filling in a lot of characters. You can see there's the graphics character set and the control characters early on, and then the usual ASCII characters. When we get up to 41, we see the A, capital A, and when we get to 61, see the lowercase a, and so on. So the lower part is a regular ANSI standard. But if we go further down, all these are defined. All these actually show up as characters you can display. Like, I think this is a dot standard for punch tape called Bodot. I never noticed that before. I actually worked in Bodot for a while. But this is a way of defining characters with dots. And probably good for Braille. I think a lot of these are undisplayable. I'm not sure why. But when we get down into like the 4000 hex, there's all these kanji and various Asian characters, katakana and hiragana. My son can actually read these, but it's beyond me. I'm tempted to tell the old joke of I can't read it, but if you turn it sideways I can play it on the piano. But that would be a very politically incorrect joke. But part of my point is I found my up arrow and down arrow graphical figures in the Chars01 console program, and they're hex 18 and hex 19. But when I tried to use these in the Windows application, it turns out it is indeed a different character set. I believe the 18 is correct, but the 19 was some other box building character or something. So in order to find them in the Windows application character set, I had to go way down near the bottom of the entire 2-byte character set, and up arrow is FFEA and down arrow is FFEC, which, as you see, is almost at the end of the entire character set. So if you look above, I have indeed put an up arrow and a down arrow in the button, and the way I did that was I put a /x FFEA and a /x FFEC to display the graphic characters represented by these hex values. And that solves the problem on the level of what I wanted to solve on the program I'm writing. One thing you can't do is go over to the form and click on the button and then go down to the text and type in here the /x and the /n and so on, because I'll just show in the button the /x, hex value, and /n, and it'll just print out the way it looks when you type it in. So you have to actually assign it to the text value as a string in order to get it to show up. So have the button name .text equals string. Well, I hope you enjoyed this video and learned a lot, and I'd appreciate it if you'd subscribe.